Hello there, welcome to another video about the RR debugger. In the first video about RR that I did, I showed you a technique that you use with RR. I call it the backup and drill down. This time I'd like to show you another technique that you can use now that you have the ability to time travel. This technique is called start at the end. And the idea of start at the end is instead of stepping through the program sort of line after line from the beginning, you reverse it. You have the program run all the way to completion, and starting at the end, you reverse step back to sort of track the calls of your issue. Usually you use this when you have an error or your program crash. I'll show you a couple of examples where this technique is applicable. So I have two programs that are sort of generating a bunch of random people names based on a list of first names and a list of last names. And it's inserting these into a SQLite database a number of times. And in both of these programs, there's an issue. So let me run the first one. This is going to be called SQLite crash. And as you can see, there's a crash. There's a segmentation fault. And I remember that when I was in college, long time ago, when I was programming in C, I used to be frightened of segmentation faults. And now that I'm coding in C again and I have access to the RR debugger, segmentation faults actually bring a certain delight to my face, and I'll show you why. So if you get a segmentation fault in your C program, here is what you can do with RR to debug it. We're gonna record the execution of this program with RR's record mode, and now we're gonna replay this program using the RR replay mode. And now we're gonna start at the end, which means we're gonna first say continue, which is the shorthand for continue is C. We're gonna say continue to have the program all the way run until completion, and you can see the segmentation fault here. And at this point in RR, we can actually print out some information about the program, I believe. So I'm gonna clear the screen. I'm gonna actually show the backtrace of this program. We actually have a line number that we can refer to. Let's see. We're actually on line 143 in the program, so let's go there. So it was on this line. More precisely, we're actually in the string len function had a segmentation fault. Now, I don't think I actually have access to this source code, but I can see that on this line, I have a call to stringling. And if stringling called a segmentation fault, I should ask, what is the value that I gave to stringling? And I actually can print that out. But at the moment, I cannot. We're actually inside of the string function, but what we could do is come out of the string function back into this context. And the way we can do that is using the reverse finish command, because we're inside the main function here. The main has called string length, and we're inside here somewhere. If we want to get back into the main function, 143, but onto this one line that's calling string length, we can say, hey, go in the reverse direction, but reverse finish is as if we're finishing the function, but we're going in reverse. So I'm going to say reverse finish. And now we're on line 143 again. So we're here, and we actually have access to all the variables in this context. So I can answer the question I asked, which is, what is the value of last? So I'm going to use the p command, print, to show me the value of last. And I can see that last is a null value, is 0. And now, naturally, I'm going to ask, how did last get a value of 0? We can read the code backwards to see where last got a value, and I can see it's here. And what's this code doing here? Well, this code is calculating a random index to get the list of last names, and that got us a null value. How could that be? Well, what is last names? Last name is this list, and then we're calculating an index for last names by using the number of first names. So, well, okay, that's probably the problem. We have a number of first names, which is 12, and we have a number of last names, which is 11. There's fewer last names than there are first names. We can't see the actual index number that was calculated because we didn't store it in a variable. But if we did store it in a variable, I imagine that would be an index that's out of the bounds of this array. I think the obvious fix here is change that to number of last names, recompile the program. Let's run this one more time, and this time we've solved the error. All right, let's see the second example. Second example is not exactly a segmentation fault crash, but nevertheless we get an error. Okay, we get an error. This time it's a database error. To debug this, again, we're gonna use the start at the end strategy. We're gonna say use record to record the execution of this program. We're gonna run it in replay mode now. And when it's in replay mode, at the beginning, it pauses at the beginning of the program. So we're gonna say continue or C to let it run all the way to the end. And now we're at the end. This scenario is slightly different from the crash segmentation fault scenario because the program actually didn't crash, but it exited with an error number. And I'll show you what that looks like. So if I do a backtrace now, I actually can't see anything, but I can reverse step by 1. So RS for reverse step. And now we're inside some kind of raw syscall code because I believe that we're executing the sysexit system call. I'm going to do a backtrace to see where we are at. So we're at a function called libStartMain. What's happening is there's this libc_start_main function is the real entry point. I believe this start is actually the real entry point. So what's going on is like that. And then there's a bunch of stuff that happens. I'll call this setup. And then your main function is getting called. And then there's a bunch of cleanup stuff that happens. And where we are right now is somewhere inside this cleanup code here. So what we want to do is sort of travel backwards in time until we hit this main function. And we want to get at it in reverse. So what we want is to sort of stop at the end of the main function. Usually I grab the line that has the closing curly bracket and I stop there. So I'm gonna explicitly set a breakpoint there. I'm gonna say break in the SQLite error.c, and then I want to break on line 163. Okay, now that I have a breakpoint set here, I'm gonna have it go in reverse. And that's reverse continue, or RC for short. And I have traveled in reverse and hit the last line of my main function, and now I'm gonna reverse step, which is RN. Again, for any of these commands, you can type it all out, or use the shorthand. In this case, RS. Actually, I'll do RN, R reverse next. So here, reverse next actually brought us to line 131. So let's see where that is. So we're actually here, which tells us that at this step, where we're trying to bind an integer parameter of this insert database statement, there was an error. So we're able to locate the database procedure that produced this error. And I don't remember what the error message was, although I think we can get it. I'll just go next. No, and it prints it out into the terminal. It says column index out of range. So what are we doing? Well, we're saying I want to set the fifth argument of this prepared statement to this ID number, and it says column index out of range. The only index I can think of is this 5. Let me look at what this insert statement is. Does it have 5 parameters? No, it only has 3 parameters. So that's probably why the column index is out of bounds. And for the next 2, I only have 2 and 3. So this should be index 1, because let's see. If I insert into person values, there's 3 value. Where's the person table defined? The person table is defined here as the first one is ID, the second one is first name, and the third one is the last name. Therefore, the index should be 1, and then followed by 2, and then followed by 3. I know you might be thinking it should be 0, but it's not 0. I read the docs. I read the SQLite docs, and for parameter binding, the first one is actually 1. So let's try this fix. So I rebuilt it and run it, and oh, this time it says no more rows available. I think I got past that error, but I have another one. So let's debug this one. All right. Again, I recorded the execution of this program, and now I'm going to replay it so that I have access to time traveling while I'm in the debugging process. So again, I'm going to run the program to completion. So we're now all the way at the end. And again, I'm gonna set a breakpoint at the end on line 163. And then now that I've set the breakpoint, I'm gonna reverse continue. And then now I'm here, and now I'm gonna reverse step 1 by 1 backwards. Reverse next. Now I'm actually on 144. I'm here. So this statement caused an error. What was the error again? It's no more rows available. Why would no more rows be available? Let me search the docs for this error code. There's the SQLite docs for error code. Let me search for 101. That says SQLite done. Actually, the error code is SQLite done. Okay. This is not actually an error code because 101 means SQLite done. So the error here is not that there was a database error, but the error is in the usage of my SQLite 3-step function. In the docs, it says if the SQLite 3-step function returns SQLite done, which is 101, the number 101, it means that the statement has finished executing successfully. So 101 should be expected. The problem is I expected this to return a 0, which it doesn't do even if it succeeds. So the fix here is to change this to say expect the return value to be SQLite done. Compiling, and then I will run this again. Oh, I should say if not equal. Not if equal. Okay, and now the bug is fixed. Okay, so that's an example of this technique, start from the end. I hope you enjoyed it. And again, if you haven't used RR before, I hope you give it a try. For one thing, it's conquered my fear of segmentation fault, and that should count for something.